Wordle. You know it, I know it. Your grandma probably knows it. But Wordle has one flaw. You can only play one a day, and one is just not enough. So I decided to make my own. I started working on the backend. I created the Wordle endpoint that currently only fetches data from an API and returns it to the browser. Then I decided to do the exact same thing for all the future New York Times games that I'm planning to remake. This includes connections, strands, pips, spelling bee, and minute cryptic. The last one's not really a New York Times game, but I'm doing it anyway. The next thing I did is I actually inserted the data into an SQL database with tables for all the games, so they can be stored on the server and they don't have to be fetched every single time. There's also this words table, but more on that later. Okay, Wordle works, connections work, strands work, cryptic works, pips work, B doesn't work. That's fine. We'll fix it later. Now, since all the endpoints are done for now, I can move on to the second, much bigger part of this project, the front end. I installed React and I was able to get some text to show up on the site. Now, I have to test if I can actually fetch the data from the backend and pass it to the front end. In order to do so, I created a new endpoint called numbers that just returns the number of games stored. Now, all I have to do is just display it. It works. After that, I added routes so that Wordle can be found under a different URL than home. Then I added database checking so that I don't have to call the API every time I want to play a game. Here, I check if the data is present in the database, and if it isn't, then I fetch and insert it. Otherwise, I just return it. Finally, it was time to start working on the actual game. I began by creating a grid to kinda get a feel for where everything will go. For now, the grid is hard-coded in this awful way with all the rows being filled with the word horse. The background colors are temporary and are here solely to visualize all the parts. The next thing on the to-do list is to make the game actually interactable, since right now it's just a static grid. I added a cell and row components so that the grid doesn't have to have a million cell divs. Now, since I'm using loops to generate the grid, I can make the grid work properly by generating a row for all the already submitted words, the current word, and the rest would remain empty. Also, I changed the style of the main div. You may have noticed that the letters get colored now. That's because I added a simple letter detection that only checks if the letter is correct or present, and it doesn't care if the letter has already been marked as correct. In addition, there is no word validation. Any random string of 5 letters can be submitted. I spent a long time trying to get the letter detection just right, and I think I did a pretty good job. I used a new data structure, for me at least, which was a map, which takes a key and a value for that key. The first thing I did is I created a map for the solution word, where every letter was the key and the value was the amount of times that letter appeared in the word. For example, let's use the word pizza. The base map for pizza would be P1, I1, Z2, A1, because there are 2 Z's in pizza and PIA only show up once. This is the reference that all the checking will rely on to color correctly. After that, we have our first for loop that actually colors stuff. This one only cares about the correctly placed letters, the greens. For each correct letter, it marks it as correct and either adds it to the scene map or increments the value for which that letter is the key. When the for finishes, we have all the correctly placed letters. And we move on to the second, more complex for. This one is specifically designed for the present letters, the yellows. It starts by checking if the letter is even in the word, because if not, we can skip to the next letter. If that's not the case, we can check if the previous 4 marked it as correct by checking if the map seen has the letter as a key. If it doesn't, we know that we have a yellow on our hands and we have to mark it as such. The bigger problem occurs if the letter appears in a scene map, because we have to determine whether we mark it as present or empty depending on the value for that letter. We check if the scene value for that letter is lower than the base value for that letter, because if so, we have to mark it as present, since not all instances of that letter have been found. The last if statement here makes sure that we don't override a previous green. Now, as expected, only the correct Z's got green. And now, only one Z got greened, and the other one got yellowed. The rest got grayed out, which is the intended behavior, since the base map had 2 Z's and scene only had 1 after the first loop. The last thing that needs to be done in order to complete the actual game aspect is to add word validation. And this is where the words table comes in handy. You see, I realized when I was fetching for strands specifically, I realized that they provide separately all the words that are valid on that board. So I decided, instead of inserting all the strands words into the strands table, I just created a separate words table that holds only the words, so that now during Wordle and when I'm doing strands in the future, I can just call it to check if the word is actually a valid English word. I created an endpoint that validates the word by returning either true or false, and then I wrote a function on the actual front-end side of Wordle that checks if the word provided by the user is actually an English word. If it is, it proceeds with all the stuff we talked about earlier. But if not, it just uses an alert to tell the user that it's not a real word. Now we just need to add the keyword, which is pretty straightforward. I just added a letter button component that will handle all the style changes for the letter. I also added an array with all the letters, and I just map over them in order to create the grid that is the keyboard. After some style changes, I managed to make it so that the letter background changes based on the letter's role. The game is basically done, but there are a few features that I wanted to add. I added a random endpoint that, as the name suggests, just fetches a random game from the database. I added a button that opens a modal and lets you pick the date that you want to play. Now time for some finishing touches. I added a function that resets all the imported variables, just to not have to reset them manually every time I want to do that. Removed the awkward alerts and replaced them with what I think is better. That is, if the word is incorrect, the whole row is going to turn red, so that you know that it's an incorrect word. And now if you win or lose, there's gonna be a modal that's gonna depict that outcome. So that's the video. As I mentioned, I do have plans to make the other ones. Actually, for the record, I completed Wordle a couple months ago, and connections and spelling bee are also already done, and I have been working on strands. I had to use Git, get the footage that you saw. If you're still here, then thank you for watching. I don't know why you're here, but thank you. And if you have any feedback for this video or the code in general, if you want, you can leave it in the comments if you really want to.